Alrighty, we got the 2018 question number 6, and they give us a differential equation, and it starts with a slope field. So they ask us to sketch the solution curve. The solution curve is what fits in that slope field. So we want to sketch the solution curve that passes through this initial condition. So that initial condition is 0, 2, that red dot right there. And you're going to notice that it sits on a row of horizontal slopes. So it's going to follow the flow as it moves to the right. It's going to follow those slopes that are already horizontal. And same thing on the left side. So that was probably some kind of horizontal tangent. All right, we're also going to draw the solution curve that passes through the point 1, 0. Now that's not going to be just a horizontal line. It's following that flow right there, okay? And then on the right side, that is the right side. On the left side, it's flowing. It's flowing. I want to try to mirror all those slopes. Okay. Oop, got kind of jagged, but so something like that. That's pretty good. So you notice that it doesn't like intersect those little slopes. Think of those little slopes as tangent lines. So my solution curve would mimic that slope of those tangent lines as it flows, as it moves to the left, as it moves to the right. All right, so that's part A, and that's probably worth 2 points. Part B says let f of x be the particular solution, blah, blah, blah. Write an equation for the tangent line. So to write an equation of a tangent line, I need a point, which I have right here, 1, 0. And I need a slope. And what I like about differential equations is our slope of our tangent line is dy dx. Okay, now this is dy dx at x equals 1 and y equals 0. So I'll replace the x with 1. I'll replace the y with 0. So at 1, 0, dy dx, or the slope of my tangent, would be 1/3 of negative 2 squared is 4. So 4/3. So now that I have the slope of my tangent and a point, the equation for my tangent line is going to be y minus y1 equals m times x minus x1. All right, and so there's the equation of my tangent line, but we're using that tangent line to approximate f of 0.7, f of 0.7. So that means I'm going to be switching out this x with 0.7. All right, so it would look a little something like this. Y minus 0 equals 4/3, 0.7 minus 1. Y equals 4/3 times 0.7 minus 1 is a negative 0.3. So y equals negative 0.4 looks like my approximation there. So that's probably a 2-point question, probably 1 point for the tangent line and 1 point for the approximation. So far we're up to 4 points. That means part C is probably a 5-point question. And I'm going to give myself some room to work here. This is big money over here. All right, so I got dy dx equals 1/3 x y minus 2 squared. So the first point is going to come from the correct separation. So I need all of my y's on one side with the dy's and all my x's on the other side with the dx's. So to do that, I'm going to take this y minus 2 squared and I'm going to divide it on the other side. Okay. And then I'm going to multiply that dx to be on the right with the x's. Cool. So that's probably 1 point. We'll get another point, maybe 2 points, Probably just 1 point from integration here. The reason I'm only probably getting 1 point from the integration is because there's no like U sub or anything like that I have to worry about. Now, before I integrate, I'm going to think of this instead of 1 over y minus 2 squared, I'm going to think about it as y minus 2 to the negative second power. So hopefully we've done enough of these to where you know that this is not going to be a natural log antiderivative because it's 1 over something to the second power. All right, so I'm going to integrate that sucker, and it's going to be the antiderivative. So it's going to be y minus 2 to the negative first over negative, negative 1. I use the reverse power rule. So my exponent, we call it the n plus 1 over n plus 1. So on the right side, we're going to integrate that, and it's going to be 1/3 is my constant multiplier, and the antiderivative of x would be 1/2 x squared plus c. Let's make this all look prettier. Cool. Now I could solve for my c right here, but I'm just going to go ahead and wait till the end to worry about solving for c. Let's solve this for y. To do that, I'm going to change the signs. I don't need to worry about changing the sign of c. It's still some random number. I'm going to reciprocate. And I'm going to add 2. So there's our general solution. Y equals negative 1 over 1/6 x squared plus c with a plus 2 tagged on the end. So there's our general solution, but we do need to find our particular solution because we have an initial condition where when x equals 1, y equals 0. So I'll replace the x with 1, the y with 0, and that'll help me find c. So we said y is going to be 0. And x is going to be 1. All right, a little bit of algebra. I'll move that 2 to the other side. Okay, I'll change the signs. I'll do the reciprocal. All right, I'll subtract 1/6. All right, and I should make a common denominator. So instead of 1/2, I'll call that 3/6 minus 1/6 equals c, and it looks like c is going to be a 2/6 or a 1/3. So reduce that to 1/3. So now that I know my value for c, I can take that and I can plug that right back in to where my general solution was. So I used the initial condition to figure out what c was, so I could go back to my general solution and now I can get a particular solution. C was a positive 1/3. Now, I know there's different versions of the same answer, and that's cool. You can probably look at that and think about how you could have a equivalent answer that looks a little bit different. Anyway, that last part was probably worth 5 points. Points would come from, number 1, the separation, probably 1 point for the integration, probably 1 point for using your initial condition. 1 point for solving for y, 1 point for using your initial condition. Where did I do that? Right here. And then 1 point for solving for c. or I guess having the correct answer at the end. So 1, 2, 3, 4, probably 5 points on that one.